Have you ever been to Los Angeles? You know the feeling, right? You're driving around, you know the Hollywood sign is up there somewhere, but finding that perfect postcard-worthy view, it feels like you're chasing a ghost. One minute it's there, the next it's just gone. Well, let's dive into this, because it turns out this isn't some kind of magic trick. It's actually a fascinating geospatial mystery. So that's the big question, isn't it? Why is it so ridiculously hard to get a good look at one of the most famous landmarks on the entire planet? The answer, it turns out, is way more complex than you'd think, and it's literally written into the ground the city is built on. We all have this picture in our heads, you know? The sign is just massive, it's dramatic, it's filling the whole frame. But the reality for most people, from most parts of the city, is, well, it's that tiny, hazy little smudge on the right. Now, your first thought is probably, oh, I'm just too far away. But the real reason is a story about geology, elevation, and some pretty surprising math. All right, so let's put on our detective hats. We're going to solve this landmark mystery, but not with clues and witnesses. No, we're going to use data points and geodetic science. It is time to officially investigate the case of the disappearing sign. See, at its heart, this is a story of two gigantic opposing forces. You've got the steep, rugged Santa Monica Mountains clashing with the vast, sprawling Los Angeles coastal plain. And their entire relationship, the thing that defines everything, is told through numbers. Numbers that dictate what you can see and what stays hidden. So to crack this case, we're going to get our hands dirty with some data. We'll be taking measurements and analyzing the view from three very specific and very different locations within the city of Los Angeles. So let's get our bearings. First up, our main subject, our target, the base of the Hollywood sign itself, sitting up there on Mount Lee. This is our anchor point. It's perched at a cool 1,570 feet above sea level. Remember that number, 1,570 feet. It's the highest point in our entire investigation. And here are our three witnesses on the ground, the places we'll be observing from. We've got the famous intersection of Sunset and Vine, an office building on Wilshire Boulevard, and the iconic original Farmers Market. Just three classic LA spots that, as you're about to see, exist in completely different geographic worlds. So let's start with Sunset and Vine. It clocks in at an elevation of 368 feet. Now, obviously, that's a lot lower than the sign, but here's the thing. For a spot that feels like it's right in the heart of the city, that number is actually surprisingly high. Keep that in mind. Okay, now look at this. We move just a few miles south to Wilshire Boulevard, and our elevation absolutely plummets to just 182 feet. Wow. We've lost more than half our altitude in just a short drive. You would never notice this in a car, but geologically speaking, the entire landscape has completely transformed right under your feet. And the nearby farmers market just confirms the pattern. 175 feet. It's on that same low-lying plain as the Wilshire spot. So here's our key clue, right? We've got one spot, Sunset and Vine, that's way up at 368 feet, and two others way, way down around 180. That elevation gap, that is the key to solving this entire mystery. Okay, so we've gathered our elevation data, we have our clues. Now it's time to bring in the science and a little bit of math to connect all these dots and really reveal what is going on with that view. Now, you might be looking at this and thinking, well, duh, it's just distance. And look, you're not wrong. Sunset and Vine is way closer, only 2.5 miles away. The other spots are 5, almost 6 miles out. But if distance was the only thing that mattered, this would be a pretty boring mystery. The real secret is how this distance interacts with that elevation data we just uncovered. And this quote really gets to the heart of it. The drama, you know, that epic feeling of the sign just looming over you, that's not really about distance. It's about math. It's all about the angle of inclination, or what we can just call the lookup angle. Basically, how far you have to tilt your head up to see the sign. And a bigger angle means a way more dramatic view. And boom, here's the solution in a simple bar chart. From Sunset and Vine, you're looking up at a pretty steep 5.2-degree angle. This is huge, because it lets your line of sight clear most of the low-rise buildings. But from the Farmers Market in Wilshire, the angle is so much shallower, like 3 degrees or less. At an angle that small, even a 4-story apartment building just a few blocks away can completely wipe out your view. The sign becomes this fragile little detail on the horizon, easily erased by the city itself. So we've seen the data, we get the math, but why is the geography like this in the first place? Well, now we get to the final reveal. We're about to pull back the curtain on the hidden geologic tiers of Los Angeles that create this entire effect. This, my friends, is the aha moment. The science that solves our mystery is called geomorphology, which is a fancy word, but it's basically just the study of how landscapes get their shape. And LA's landscape, well, it has a very specific two-part story that explains everything we've seen so far. And honestly, the best way to think about this is to imagine the city is a giant theater. Sunset and Vine is located on what geologists call the proximal Piedmont. Think of this as the mezzanine section. You're on a higher shelf, closer to the stage at the foot of the mountains. Wilshire Boulevard and the Farmers Market? They're down on the distal alluvial plain. That's the orchestra pit, the flat basin floor, way down low and much further back. You're either sitting up in the mezzanine, or you're down in the orchestra pit. So the whole thing boils down to this. That 200-foot difference in elevation between the mezzanine at Sunset and the orchestra pit at Wilshire, that's the whole secret. It's a massive geomorphic boundary that's just hiding in plain sight. It's what gives you that steep, dramatic look-up angle from the Piedmont and that shallow, easily blocked angle from the basin floor. It literally creates two different cities with two completely different views of the same landmark.
Now, here's where it gets really, really interesting. This hidden geography doesn't just mess with your tourist photos. It has profound practical consequences for how the city of Los Angeles functions every single day.
You see, Mount Lee isn't just home to a sign. It is a major telecommunications hub, packed with antennas. And radio waves, just like your eyeballs, need a clear line of sight. So from the mezzanine, that steep 5-degree angle gives a nice clear shot over the buildings for a strong signal. But from down in the orchestra pit, that shallow angle means signals are way more likely to get blocked, and that means weaker reception. Your cell service can literally depend on which geologic zone you're standing in. Wild, right?
And it just keeps going. That shallow view from the basin means you're trying to look through almost 6 miles of the city's densest smog, making the sign super hazy. The actual path of Sunset Boulevard itself was determined by this geology. It naturally traces the dividing line between the steep hills and the flat plains. And of course, real estate agents know all about this. A house up on the mezzanine with a clear view is worth a whole lot more than one down in the orchestra pit.
So the next time you're in LA looking for the Hollywood sign, you'll know the secret. It's not just about where you are, but about your seat in a grand geologic theater. And that kind of leaves us with a final thought to chew on. What other invisible lines and hidden topographies are shaping the views, the signals, and the very structure of the city where you live?